Grade 11 and 12. Today we're looking at section 7.4, reciprocal functions. So here I have a graph of a line, and I want to see if I can determine the equation of this line. Well, I have my y-intercept is 2, and it looks like I rise 1, 2, 3, and run 1. So that probably the equation of this is going to be 3x plus 2. Y equals mx plus b. Positive slope. So let's check if I got that correct. Good. 3x plus 2. Now, what happens when I graph the reciprocal? What does that look like? Look at that there. Do I see any patterns? I'm going to get rid of some of my points here. It takes this general shape. It looks like it approaches a value, but it never quite touches it. It looks like if I were to draw a line where x equals negative 2/3, it looks like it approaches that point. Another thing I want to point out to you, how does negative 2/3, how does that compare to the original function and the vertex, and the denominator of the reciprocal? You'll notice that that's a non-permissible value. Ooh, that's a word we like to use. A non-permissible value is like a line that it never crosses. That's called an asymptote. We're allowed to say asymptote in class. Okay, a couple other things I want to point out to you. We have invariant points. Okay, invariant point means it's found on both graphs. We have an invariant point there, an invariant point there. There's something we might have to notice about the y value. 1 and negative 1. Interesting. Okay, let's try another one here. I'm showing you the punchline already. Here we have another line. I can see that my y-intercept is negative 7, and it said it has a slope of negative 2. So if I rise 2, 1, 2, then I run back. I have a negative 1, 2 and 1. If I go up 2 and back 1, that is my slope. So what's it going to look like if I graph the reciprocal, or 1 over negative 2x minus 7? And let's see what that looks like. Why don't I turn on projector mode so you can see it? Okay. Again, we see some interesting things. If I were to graph the line x equals negative 3, that isn't at all what I want to graph. X equals 7/2. Negative 7/2. You'll notice that we have a line that it approaches, but it never touches. And how does negative 7/2 relate to the denominator? It is the non-permissible value. You'll also notice we have some invariant points found on both graphs. Again, look at those y's, 1 and negative 1. What were the invariant points here? Oh, 1 and negative 1. Invariant means it stays the same. It's on both graphs. Here we come up, we approach, and then we get really, really close to 0. But y never equals 0. Did that happen here? Oh yeah, we got really close to it, but we never quite met it. So we might be starting to see some patterns, hopefully. What if I have a graph of a quadratic? Here I have a beautiful quadratic. It's x squared minus 2. We should know how to get the graph, the equation of the graph from it. Here's my vertex. My vertex is 0 and 2. Remember vertex form where y equals ax minus p squared plus q. Oh dear, that's coming back. So my vertex is 0, negative 2. So my p value is 0. My q value is negative 2. Now we have some x-intercepts. Interesting. There's my x-intercepts. Those are going to be the square root of 2 and negative the square root of 2. Now watch what happens when I graph the reciprocal, or 1 over x squared minus 2. What does that look like? So it's like there was two vertical asymptotes on the non-permissible values where the denominator could not be 0. It approached those two lines. We had some invariant points. In this case, I had 4 invariant points. And look at the y values here. 1, -1, 1, -1. So the points that stayed the same are there as well. So hopefully seeing some patterns. We're going to put it together in a second. Here I have y equals x squared minus 5. Okay, again, my vertex is at 0, -5. Put it in vertex form. That's where the equation came from. I have some x-intercepts right there. That's going to be the square root of 5. Oops. And negative square root of 5. Where does this function equal 1? Well, it looks like right, I'm going to get rid of this. This function equals 1 right here, close to that, and right there, and it equals -1 there and there. I wonder if those are going to be my invariant points. Let's see. Look at that, my invariant points. Again, whenever the function equals 1, and whenever the function equals -1. Okay, a couple other things. There's like an asymptote. It approaches the line right there. And again, it approaches this line there. Those are called asymptotes. We also have a horizontal asymptote, a line that it comes really close to but doesn't quite cross. So it's kind of these two basic shapes of reciprocal functions. When it's a quadratic, it's going to look something like this. And then when it's linear, we're going to have something like that. Okay? And I'm going to teach you where we pull information from. So this is a handout that you have. If given a graph, you need to find the equation. That's the first step we're going to do. Check with Desmos. So our skill set that we have is it's linear. We can use y equals mx plus b, where m is the rise over run, b is the y-intercept. Quadratic, we can use ax minus p squared plus q, where p and q is the vertex. And you can find the value a by subbing in a point and checking. So since we know p and q, we can find another point on the graph and solve for a. Most of the time, a is 1 for the questions I'm going to give you. Okay, then we need to find the equation of the asymptotes. Always we have the horizontal asymptote of y equals 0. Always, for linear or quadratic. So this is a given. You're always going to have y equals 0 as your horizontal asymptote. Your vertical asymptote is an equation again. It's going to be x equals the values of the x-intercepts. So to find the x-intercepts, we need to solve the equation, either using algebra, factoring, etc. Linear, we're going to have just one vertical asymptote. Quadratic, we can have up to 2 vertical asymptotes. Okay, here we have our first problem. So step number 1, we're going to try and find an equation for this. This is a quadratic. It is a parabola. So I know that I'm going to be using y equals ax minus p squared plus q. My vertex in this case is 0, 9. So I'm going to have x squared plus 9. Subbing in a point, I could sub in 3 and 0. So I have 3 squared is 9. So 9a plus 9 equals 0. Well, a has to equal 1. Wait a second. X squared. If I put in, the point is 3 and 0. So 3 squared, a must be -1. I know what I did wrong. Okay, sorry. This should have been -9, and then I forget what I'm doing. Okay, my Q is -9, but I wrote, there we go. So if we put 3 here, 3 squared minus 9, sub in the point, 0. A times 9 minus 9 equals 0. A has to be 1. So the equation of my line is x squared minus 9. Step 1. Step 2, I need to find my asymptotes. Okay, I always have the asymptote y equals 0. That's a given. Now to find my x asymptotes, or my vertical asymptotes, what I have to do is I have to find out where y is 0, and that happens at 2 points, -3 and 3. So my asymptotes are -3, and the other equation of the vertical asymptote is x equals 3. After this, I have to find my invariant points. So wherever on my graph y is equal to 1 or -1. So here's an invariant point. There is an invariant point. Okay, so that looks like invariant points. It looks like I have just under 3, so let's just guess for this point. And the ones you're going to do, actually I don't need to guess, I can sub in. Sorry. So 1 is equal to x squared minus 9. X squared equals 10. So x is going to equal plus or minus root 10. Okay, that's what they are here. And root 10 is a little bit more than the square root of 9, which makes sense because we've done, when we said 1, we're talking about this point kind of right up here. So there's the invariant point. Sorry, 1 right there and 1 right here. Those are my invariant points. Okay. Also -1 we have to look at because that's where it equals -1. That's the other invariant point. So when does -1 equal x squared minus 9? Well, I add to both sides, so I get 8 equals x squared. So I get x equals plus or minus root 8. That can be simplified to be x equals plus or minus 8 is 4 times 2. So I get x equals plus or minus 2 root 2. 2 times the square root of 2, which is a little more than 1. That makes sense. So there's my invariant points. We said my asymptotes are going to be right here. So let's choose a different color, and I'll draw in the asymptotes. Asymptotes are generally put as vertical lines. That asymptote here would be x equals 3. Again, those are x-intercepts. Okay. And x equals -3. So we'll put -3 to the asymptote here. X equals -3. And my horizontal asymptote, I said, was always y equals 0. Okay. So I have some invariant points. I have my asymptotes. Step number 3 says take reciprocals of each of the points. Okay, 0 and 9. I'm looking at those y values. So the reciprocal of -9 is -1/9. So 1/9 would be somewhere around here. Then I'm going to come over here. Right here I have -7. So I need 1/7, and 1/7 is bigger than a 9. So I start getting bigger. What about 2? Here I would have, oh, that should be probably a little more up there. I have 1/9 at the value -2. That would be -1/2. Here I come to my invariant point right here. Here is where I have like the value 1/2. Well, the reciprocal of 1/2 is going to be 2, negative of course. Here I have 1/7. That's going to keep moving up. And imagine I get 1 millionth. That's going to keep moving up, up, up to 1 millionth. So I'm going to have a general shape that it's going to go like that. Same thing here. As I take the reciprocal, it's going to come through that invariant point and come down. This should be nice and curved. Nice and curved like that. Okay? Over here, I have my invariant point. As I get closer and closer, I get fractions. And the reciprocal of fractions like 1/2, 1/1,000,000th keep going up. Here, as my values get bigger, the reciprocal gets smaller. Okay, same thing here. I'm going to have, that's my invariant point. I'm going to come down and it's going to look something like this. So that is what my sketch would look like. And lo and behold, I have already graphed this. So let's see if that is indeed what happens. So here's what our graph looks like, and this is what the reciprocal looks like. I'm going to turn that off. So some of the things that we said is we said that we're going to have an asymptote at about x equals -3 and +3. That was correct. And we also said that we're going to have a horizontal asymptote there. What about those invariant points? Let's see if they are where we said they were. Let's turn off those. So I said I had invariant points right there, right here, there, and there. So all the values were equals 1 and -1. So we had said that those values were, where did we have it here? 2√2 plus or minus 2√2 and plus or minus √10. So my question to you, is that the same as these values? I'm going to get you to get out your calculator and check that. So hopefully you had a chance to check. If you're still checking, press pause on this video because I do want you each to do this on your calculator to show that it's the same. Okay, once that's done, you guys have 2 questions like this. The first one is a line. The second one is a quadratic. That's 13 on page 329. The other ones, you're going to actually have to sub in values and then take the reciprocal of the values for question 14. And question 15 is a word problem that's actually much easier than the graphs. Make sure you use Desmos. Make sure you're checking your answer, and you use the printout that I provided for a little bit of guidance of what to do. Have a good day.